Okay, this is Eric Linwood with more self-elevated / spring power universal exoskeleton armor updates. And I basically got the armor set out. I'm still doing some little bit of modification on the heavy duty. And I guess I apologize to a lot of people, like for I was like a lot of followers. They were like, "Oh, why don't you do this with the suit? Why don't you show the suit? This and that." I just had a lot of, like I said, I had a lot of modifications I was doing. Right now, I'm finna extend this piece right here. I cut a new piece. I'm finna extend the frame piece on the thigh area here, and basically I'm changing this tube out for this longer tube structure, and it's what it's gonna do is it's gonna raise the length of the actual exoskeleton for the belt, because last time I wore it, it was right in this area. It was riding the hips a little too low, so I brought it up. As you can tell, it's just about a half an inch to an inch, about 3/4 of an inch is what I did. And that basically pulled it off. It's gonna pull it off my hips and put it in the right position. I did it the way I built it is customized, tailor made. It basically only fits me at my height. It is semi-adjustable around the waist and the thigh and the calf muscles, but for the main part, I did it for security reasons. I didn't want nobody to get a hold to it and be able to just flop it on. And then also, if you look at exoskeleton technology, a lot of companies, they mention it, a lot of exoskeletons, they got to be customized to the user. That's another reason why I made it simple, because so it'd be mass producible. You can always recreate something with your hand over and over and over, but you're doing it by hand. Machines are a lot faster, and for its manufacturing parts over and over and over, their repetitive nature, than humans, and you take out the human error. But unfortunately, humans, besides 3D printing, could just basically, they don't, like I said, build to the degree of a robot for its no human error, but a human does have like better customized pieces depending on what you're building. It's just that when you build a piece that's so customized, even though a computer can build at a faster rate and more of it, it's just harder for that computer to actually, even as good as computer and 3D printing and stuff is to basically mass produce that part over and over really fast. The more complicated it is, the harder it is for that machine to mass produce it over and over and over really fast. So that's another reason why I got the simplicity. And then also is to take down cost. You actually got guys now that are being employed by like Boeing, Lockheed, and different other organizations. And this one guy, he did a helicopter, and this particular guy, he's basically specializes in taking equipment that is very, very complex in manner and basically making it very simple, but still giving the same end result. And that's another thing that I'm trying to do, and that's going to drop down cost. One of the most simpler engines in the world is the jet engine. It's a turbine jet engine. But at the same time, they made it more and more and more complex over the years. But it's literally one of the most simplest engines there is. Also, if you YouTube or like Google amphibious bikes, there's a bike on Google YouTube. It's a yellow bike. It's encapsulated bikes, 3-wheel design, and actually go on land, water, and basically human powered. It looks very simple. I'm gonna post a picture of it later on my Google site, and I'm putting this on YouTube and Google. That's why I say it like that. But they actually had like some of the most top analysts in the world, top manufacturer in the world. And I'm telling you, the amphibious bike, it looks simple, but they literally said the bike, even though it's revolution in technology, that it was literally too expensive, as simple as it looks, to mass produce and to gain any profit from it. That's why it's not mass produced. So that's another thing. You don't want to build something so complex or so hard to build that nobody wants to buy it, nobody wants to manufacture it, because it's too expensive to actually manufacture or for someone to purchase it. So that's another thing by making it simple in Notion. Another thing that I went and did for as modular The reason why, for one, I made it modular is because for the heavy duty one, it was the most um, Forest that I had to make module just because of the physical nature of itself. The suit is alone, the whole thing weighs over surrounding around 100 pounds or more. If you have one solid piece with the upper extremity, the arms, the boots, everything, just one full suit. I mean, unless you have it on a stand and with the flexibility that I have it at, being it is not power, it's not locked in. It's not just standing up by itself. The full for is just the balancing of it. I mean, it holds itself up, but being that the springs are super flexible, it still got a balance. The double jointed springs on the heel, on the lightweight and the EDF combat that problem when you're doing the legs and it just stand up and it really auto balances. The springs has enough auto balance to keep that up. But when you put the upper extremity on that one, being that the spine is so flexible, it starts to go off balance and it still will fall over. But if you were just to hold your hand on it, it will still be holding it up. But with this one, like I said, for as also injuries, I made it modular because if you have an arm injury, a leg injury, a foot injury, an injury to the chest, injury to the back, I wanted it for a med or MD or a field soldier just to be able to take it off and dress that wound without embarking from the whole suit. That's another thing. If you're injured in the field and you got this good protection on, if you're injured, okay, now say if just your arm injured or just your back injured, you don't want to take that whole suit off and leave the rest of your body vulnerable to frags or maybe a grenade land beside you, a mortar land beside you, or enemies still shooting at you. You don't want to embark from the whole suit. So you want to take just the part off you need to dress the wound, put the tourniquet on it, whatever you have to do, put the armor back on the person. If he's got to sit on the sideline, he's still fully armored. He didn't have to come out of his whole suit, leaving his rest of his body vulnerable after he's already sustained injury to another part of his body also. Also, for just on a personal notion and just on the actual, just for as a consumer notion, I made it modular because I wanted the parts from this heavy duty suit and the lightweight suit and the EDF suit to be universal in nature and modular in nature so they fit each other. My lightweighted back piece and my heavy duty back piece will fit both these heavy duty legs and the light duty legs, and vice versa. If I had the light duty legs, I could actually put the heavy duty back piece on the lightweight legs or just use the lightweight. I did the EDF legs, and then what I end up doing is I put this piece on the belt and it basically receives the artificial spine. Like I said, I made it simple in nature, and so it's reliable. When you have a lot of complex parts, moving parts, you see it in engine manufacturer, and a lot of engine manufacturers, they do it. A lot of jet manufacturers, even though it's complicated as you see them, trust me, they could be a lot more complicated, and they literally found a complex solution and make it simpler for mass production. And for is when you have something mechanical with a lot of moving parts, there's just a lot that can go wrong. And it's even more so, that's why I try to stress to people, it's even more so, it's already a problem when you just got a regular car going down the street. It's already a problem when you have a space shuttle going into space or airplane flying. Now you add gunfire and blast to the mix, you're looking at objects for its bullets, projectiles and stuff that can damage that equipment. The more moving parts you have, the more chance of you having something go wrong or something break, gears jamming up, motors burning out, things of that nature. A main thing you see it in is the best thing I always say. If you go back to I used to look at Robot Wars, some of the best robots out there in Robot Wars that are made to take damage, they're made to hit each other and destroy each other or protect each other from each other, are the fighting robots. And if you look at the fighting robots, the best ones are a lot of times are the most simplest design. They have the less moving part. Just probably got some big rotating discs on there, causes a lot of mayhem, knocks the arms and detracts off those other vehicles, but they're built in a manner to where their wheels are not exposed, to where it's just a uniform structure like a turtle shell with maybe just a blade spinning out the front. As simple as possible. And if you research that, those are the kings of the robots. Most of those robots that they do when they put the drones in those arenas, they get tucked out. When they put the robots that's very tall, that don't have a low center of gravity, they get knocked over. They can't pick themselves up. The arms get knocked off of them. The gears jam up. I mean, you name it. One of the main regulations in robot wars, especially if you run lithium or nickel or lead acid batteries, they make you run like a half inch to a 1 inch thick aluminum box around that battery, so if it explodes or so the other robots can't hit it and rupture it. Okay, they do those things for a reason, and you're gonna be looking at those same problems when you look at exoskeleton in the field for its robotics. You got the armor. That's what I was telling a lot of people. The main problem with heavy duty armor for its being bulletproof is, over the years, is the fact that the main reason it was too heavy for the person to just hold it up and carrying it around, right? You just need a simple elevating system for that. And that's what I did with the springs. I elevated with the springs, but you have some of the exoskeletons, and another reason why you ain't seen a real Iron Man suit, because the fixed knee and systems on the hips and the knees and the ankles, they limit the mobility of the person so much that it's kind of defeating the purpose. It's kind of you're holding the armor up now, but you can't move in it. I mean, that's what the springs are good for. They're flexible in any direction you want, but still provides lateral stability. And then also when you're going into bends, lunges, climbing up ladders, stairs, things of that nature, the springs build energy. When you're jumping down, instead of having the full bear of the weight land on your body, the suit holding itself up for one, and then for its muscle or tendons, that's what the springs are good for. It takes that force of gravity and the weight of the armor, and when it presses down on your body through your natural body motions, it actually acts like shocks in a car or in suspension, and it basically slows the descent of the armor. And then as it slows the descent of the armor, all that weight is basically building energy in the spring. So when you go back to self-right, all that energy that you just built up in the